Now the electric field at a point on the equator of a dipole. So this is the, if you have say plus q here and minus q here, so the line joining the two electric charges of a dipole, this is called the equator of a dipole. So if this is a dipole, this is the perpendicular bisector. If I make a line here, this is a perpendicular bisector, then this line is known as the equator. So we need to determine the electric field at a point, say some here, Q, capital Q. We need to find out the electric field due to this dipole at point Q, which is on the equatorial line. So point Q is say at a distance y, from the center of the dipole. That means this distance is y from this point to this point. So the magnitude of electric field due to these two charges plus q and minus q will be same, since they are at equal distance. This distance is equal to this distance. So the electric field will be equal. If we find one electric field, we can just multiply it by 2, right? And the magnitude of the electric field because of this plus q will be what? E plus will be k into q by y square plus a square. How this y square plus a square has come? See, this is y. From here to here it is 2a. So this is a from this point to this point, and from this point to this point it is a. This is y. This is a. So what will be this distance? A square plus y square under root. So because the electric field is k by q by r square. So this is r. R square will be a square plus y square, or y square plus a square. That is why we have written it as y square plus a square. And similarly, because as we discussed, the electric field will remain same for the negative charge also, it will be k q by y square plus a square. So the direction of E plus and E minus, the electric field at point Q is like this. See, the electric field would be, because of plus Q it will be like this, because of minus Q it will be like this, because of plus Q, because of minus Q. So the resultant will be this one. So the component of this E plus and E minus normal to the dipole axis, these are what? Because of this, let us take this one. It will be, if this is theta, because of this E plus, this will be E plus cos theta, and this will be E plus sin theta. This will be E plus cos theta. Similarly for this, which is E minus, what will be the component? Again, this E minus cos theta will be in this direction, E minus cos theta, and E plus cos theta will be in this direction, E minus sin theta, sin theta, E plus cos theta. So this is, so see, this E plus cos theta, E minus cos theta in this direction, E plus cos theta in this direction, so they are cancelling out. So we are not going to use this. But see, because of this E plus, we have E plus cos theta. So E plus cos theta is here, and E minus cos theta is also in this direction, right? So these are going to add up, these are going to cancel out, but these are going to add up. So we are going to add these two. So what we are going to do here is E plus and E minus cos theta we are going to add because of superposition principle. So what we are adding is E plus cos component and E minus cos component. These two are to be added. So when we add this, we just found out E plus and E minus. E plus and E minus you can directly use, and then because the direction, the component, these two are we are adding and they are in the same direction, the net electric field Q is opposite to P cap, means the unit vector. The net electric field will be opposite, so we have to use a negative sign, right? That is why we are using negative sign. So we add this one, with this we know cos theta is given by base by hypotenuse. What is cos theta? What is cos theta? Cos theta is base by hypotenuse. Base is a, hypotenuse is a square plus y square, as I suggested earlier also. So a by y square plus a square or a square plus y square. This is under root, right? This distance. That is why we wrote cos theta as base by hypotenuse, that is y square plus a square under root. So when we just solve it, we get this expression. Now I hope you got the idea of negative. The net electric field at point Q is opposite to this p cap, which is the normal vector, which is the unit vector. So because of the negative direction, we have taken negative sign. Now when we this is the expression actually, and this we have to use in the solution of the problem. Now there is one thing here, that if this y is bigger, quite bigger than a, we can just neglect this a. So if you remove this a, you get expression, this will be removed, y square to the power 3 by 2, 2 cancels, y cube, only y cube will be remaining. So this is k p cap, and like this. So here we see that the electric field of a dipole at large distance does not fall as 1 by r square. In fact, it falls at 1 by r cube. This is y cube. Here also we see it is z cube. For electric field at a point on the axis of a dipole or electric field at a point on the equator of a dipole, both ways the electric field falls for a dipole with respect to 1 by r cube, right? Or you can say electric field is inversely proportional to r cube.